as we started to compare different building standards with one another, the first thing we had to look into is if a building standard was applicable to certain projects or not. For example, California Title 24 applies to projects located in California, and it would not make sense to try to apply that to projects located in Maine or Florida or Colorado. Similarly, the 2021 Fuse Core Prescriptive applies to single-family homes with a certain cap on the square footage per bedroom. So that was a limit on building size, for example. And Pretty Good House per se does not list any limitations to its applicability. It actually lists no standards and no boundary conditions. But the information we found on the Pretty Good House website and book lists prescriptive requirements for climate zone 5 and 6. So we applied Pretty Good House to projects located in climate zone 5 and 6. Considerations include the fact that when we look at metrics such as comfort, California Title 24 is going to look very good, but that is not because it's a very strict standard, on the contrary, but because it's applied to very mild climate zone. Similarly, for Pretty Good House, some of the results we're going to see for the energy performance are going to be impacted by the fact that we only used the standard for projects located in climate zone 5 and 6. We're going to come back to this. This is a table where we list all projects. Again, the very first one at the top is the smallest. The numbering is consistent. Project number 1 is always number 1 in all of these tables, and it's always the smallest. And number 50 at the bottom is always the largest. And in the green boxes, you see where the standard was applicable. California Title 24, the 2021 Fuse Core Prescriptive, and the Pretty Good House. And so when we look at results for individual standards, you will see some blank cells, as we see on the right-hand side of this table, because that standard was not applicable for that project in those conditions. That is kind of leading towards understanding those tables a little bit better. Starting to talk about requirements, IECC for the International Energy Conservation Code, we looked at the prescriptive compliance path, and we looked at the minimum R values and maximum U values and air leakage and ventilation for the 2018, 2021, and the official draft for the 2024 update for the IECC. And we selected the prescriptive compliance path because in conversation with city officials, they confirmed that that is the prescriptive path is by far the most widely adopted because you don't have to do energy modeling. You can just use the prescriptive values listed in the standard. In trying to have an apples-to-apples comparison, as I mentioned earlier, these projects are going to be all electric. All of these we assume to have continuous ventilation, although the ICC does not require that. But we looked at the continuous ventilation per the requirements of the International Residential Code, IRC. And then we looked at the basic heat pump for heating and cooling. What basic means, we're going to see next in an upcoming video when we talk about heat pumps. And then we assume a heat pump water heater for domestic hot water. California Title 24 similarly applies only to California. We looked at the prescriptive path. Some requirements were derived from the reference building. There are requirements in California Title 24 for heat pump minimum performance as well as minimum installation of photovoltaic system. We're going to see later what that means. Assumed all electric and heat pump water heater for apples-to-apples comparison. Energy Star and DOE Zero Energy Ready. Some requirements were derived from the reference building. Otherwise, similar consideration apply as California Title 24, in that both Energy Star and Zero Energy Ready have requirements for heat pump performance. Pretty Good House, there is no defined list of requirements. we EMU, put together a list of indicative requirements for the purpose of the study, sourcing information from the Pretty Good House website and from their book. This is what it looks like. The assumption is the all electric. We assume continuous ventilation per the International Residential Code specs. That is based on what is written in the Pretty Good House book. And then looked at pretty good, basic heat pump for heating and cooling, and assume heat pump water heater, just like every other project. For Fuse prescriptive, we derived the requirements from Fuse location-specific requirements, so from the Fuse map. This standard has requirements for air source heat pumps, so we looked at that, and we assume heat pump water heater for domestic hot water, just like every other project. Fuse performance-based is you have websites where you calculate based on your location, size, form factor, you calculate the maximum allowed heating demand for your project. So we did that, but because of the difference, Fuse and PHI set the heat and cooling demand criteria on assuming 68 degrees interior temperature and for the heating season, and 77 temperature inside the house during the cooling season. We set up the PHPP files to meet that, and then we upped the conditions to the 70 and 74 degrees that we decided to have for this study. Apples to apples, we went all electric, assigned a basic heat pump, and we had a heat pump water heater. Similarly, for the requirements with PHI, we set up the PHPP models to meet the heating and cooling demand for the PHI passive house and PHI low energy building for 68 and 77 degrees. Same consideration with Fuse before. And then we changed that to the 70 to 74 degrees setting that we decided to have for this study. Apples to apples include all electric, basic heat pump, as well as heat pump water heater, as we're going to see later. This results in these are the maximum allowed heating demand at 68 and 77 for Fuse and PHI, and this is for the cooling demand. This is what that looks like for the heating and cooling for individual projects. Dark orange is PHI passive house in the little bubbles. Light orange is PHI low energy building. Light blue is the 2018 Fuse core, and the darker blue is the 2021 Fuse core performance based. You see that for heating, PHI has constant 4.75 for passive house and 9.5 for low energy building, whereas on the right hand side you see that the darker orange and the lighter orange bubbles are not as constant, because that is for the higher dehumidification allowance that PHI allows, and it's calculated on a project specific basis for humid climates. Co-certification requirements is something that I found interesting in compiling this study. We are going to talk later about the EPA Indoor Air Plus standard, which we're going to talk about when we talk about indoor air quality. But if you're pursuing that, you are required to certify the building also with Energy Star. Now, for the DOE Zero Energy Ready Home program, you are required to have the EPA Indoor Air Plus, which requires you to then certify with Energy Star. If you're pursuing Fuse Core and Fuse Core Prescriptive, you are required to do the Indoor Air Plus, which requires you to have the Energy Star, and you also required to have the Zero Energy Ready Home. So there's kind of like these certifications are kind of nested into each other. And that adds, of course, to the level of work that you have to do for each project. PHI does not have any of these co-certification requirements. I found the Indoor Air Plus interesting and I may do that voluntarily for my own house in the future. But again, these requirements are not part of PHI's process.